writing equations of parallel and perpendicular lines. Let's start out with graphing some equations. So each of these coordinate planes has two equations. I'd like you to pause the video if you're doing this for the first time and see if you can graph those four equations, two on the first plane and two on the second. And then come back and check your answers with me. All right, now that you're back, hopefully you've tried graphing these on your own. I'm going to graph this first one. Y equals 2x plus 3 has a y-intercept at positive 3 and a slope of up 2 over 1, or down 2 and back 1, giving me this line right here. And the second one, y equals 2x minus 4 has a y-intercept at negative 4 and also has a slope of up 2 over 1. Do that a few times, connect the dots, gives us this line right here. And this represents two parallel lines. Right, parallel lines being lines that never intersect. Shown there. And you can see the one thing that we recognize about the slopes in these equations is that the slope 2 and the slope of 2, right, those slopes are the same. That is the key feature of parallel lines, is that their slopes are the same. Very important. All right, next up, your other two lines. We'll go purple for our first one. Y equals 2x plus 1 has a y-intercept at 1, has a slope of up 2 over 1, or down 2 back 1, giving me this line. And the other equation, y equals negative 1/2 x minus 2 has a y-intercept of negative 2 and a negative slope. So I'm going to go down 1 over 2, giving me this line here. And these lines have a special relationship in that they cross each other at a perfect 90-degree angle right here. So lines intersect at a 90-degree angle. We call two lines that intersect at a 90-degree angle, we call them perpendicular. If you notice the slopes of those two lines, they also have a special relationship. One of the slopes is 2, and the other is negative 1/2. And 2 is the same as 2 over 1. So the relationship between those two slopes is that they are opposites. Opposites meaning one's positive and the other's negative. And they're also reciprocals. Okay, slope is rise over run. And if we switch the rise and run, that makes it a reciprocal. All right, so very important relationships. Make sure, put that onto your cue sheet so you have that information. So let's take a look at how to write some equations for parallel and perpendicular lines. Example 1 at the bottom says write the equation of a line that passes through the point negative 3, negative 2. I'm going to go ahead and plot that point. Negative 3, negative 2 puts me right here. Negative 3, negative 2. And there's an infinite number of lines that go through that single point. But the other bit of information we have is that our line is going to be parallel to the line y equals 2x minus 1. And as soon as you see that word parallel, you know that it's going to have the same slope. So let's go ahead and graph that line. Y equals 2x minus 1 has a y-intercept at negative 1 and a slope of 2, so up 2 over 1. I have this line right here. Now, remember, my job was to write a line that goes through my blue dot, but is parallel to my purple line. And we know it has to have the same slope. So if we were drawing the picture, we would know that we could start at this point and go up 2 and over 1, just like we would do from a y-intercept. And now we would have two lines that would never intersect right there. But my job was to write the equation for that blue line. And since I know the slope and I can see where it's crossing the y-axis, so I also know the y-intercept, I could write it as y equals 2x, same slope as my first equation. And I notice that it's crossing the y-axis at 4. So I could write that equation, or I could use the point that I have and write it in point slope form. Y minus the y-coordinate of negative 2 is adding 2, slope of 2, and x minus the x-coordinate, which is negative 3, which makes it plus 3. So either of those equations would be the equation of that blue line. All right, well, we're not always going to have a graph. So let's try some where we don't need to go through the graphing process. So take a look on page 38. First one says, write the equation of a line that passes through the point negative 2, 11. All right, so they're giving me an x and a y value. And they're saying that it is parallel to the line y equals negative x plus 5. As soon as I see parallel, I know same slope. So I'm going to go over to this equation, and I want to identify the slope. Since this is written in y equals mx plus b form, I can see that my m is the number in front of x. A little sneaky in this case. It's actually a negative 1. Right? Pretend that that 1 is in front of the x there. So now I have slope, and I have a point. So I'm going to write this in point slope form. So y minus my y-coordinate of 11 equals my slope, negative 1, and then x minus the x-coordinate of negative 2 makes it plus 2. And that's the equation of the line through that point that's parallel to that line. And we could also rewrite this in slope-intercept form by using the same steps we've been practicing. Distribute, no parentheses, to get rid of the parentheses, and add your constant over. So y equals negative 1x plus 9. This and this, both equations of that same line that would go through that point. All right, another skill that we may need is to be able to determine whether lines are parallel or perpendicular to each other. And this really is just all about slope. So anytime you're seeing the words parallel and perpendicular, just know that you really need to focus on what is the slope of that line. And they've given me 3 lines here. I got line A, line B, and line C. And basically I'm going to compare the slope of each one. So my first equation, y equals 5x minus 3, is in slope-intercept form, I can identify the slope right there. That has a slope of 5. Easy one. Already written in a way that I can identify it. Line B is not. Right? Let's rearrange this into slope-intercept form so I can see what the slope is. I'm going to move my x term to the other side. 5y equals negative x plus 2. And then I'm going to divide everybody by the 5. Remember, this is like having a 1 here. So you got y equals negative 1/5 becomes the slope. And I don't even really care what the y-intercept is. Doesn't matter at all to me. I really just need the slope. So I have a slope of negative 1/5. And now I can compare the slopes of these two lines. They're not the same, so they're not parallel lines. And then I'm going to check and see if they're opposite and reciprocal, which these are. So these two lines are perpendicular to each other. Because 5 over 1 and negative 1 over 5 are opposite reciprocals. Let's take a peek at line C, see how it compares. I need to solve for y, so I'm going to move my x term to the other side. And divide by the coefficient. And I get y equals, looks like I have 2 divided by negative 10. I'm going to simplify that fraction to negative 1/5. There's my slope. Right, my y-intercept is nothing here, plus 0. It's going through the origin. Doesn't matter. I'm most interested in the slope. The slope is negative 1/5, which happens to be the same as this one, making these two lines parallel to each other. All about slope. Compare the slope of each of the lines. All right, take a minute, try the practice problem. So pause the video now, give it a try, and then come back and compare to the answers I'm going to put up. All right, so after I rearrange each of these 3 equations and compare the slopes, I see that these two are opposite reciprocals, making them perpendicular. And these two are the same, making these two parallel. And these two would be also perpendicular to each other. All right. Last example has to do with writing a perpendicular equation. The last one's on page 39. How to write the equation of a perpendicular line. Same idea. They have given me a point, right? So I'm trying to write the equation of a line through this point. Here's my x and my y. But this time it is perpendicular to this line. Right, now perpendicular is my big hint that I need an opposite reciprocal slope. But when I look at this line, it's in standard form. And I can't see what the slope is. Just like we had to rearrange before, we're going to need to rearrange this. So 4x minus 2y equals negative 6. Moving my x term. And dividing by the coefficient, I get y equals 2x plus 3. Really what mattered was this slope. Right? So I have a slope of 2. But I want to be perpendicular to that line, so I don't want the same slope. I need to change this to its opposite reciprocal. I want a slope of the opposite, meaning it needs to be negative. And reciprocal means I flip that fraction over. So I'm going to have a slope of negative 1/2. It doesn't say what type of equation to write it in, so I have a point. Remember, this is my point up here, the 4, -5. And I have a slope, so let's go write it into point slope form. Y minus, my y coordinate is -5, so that becomes +5. My perpendicular slope is -1/2, and x minus the x coordinate of 4 goes right there. And you can rearrange it if you want into slope intercept, or you can just leave it like that. That's the equation of a line. All right, pause the video for a minute, practice with this last one, and then come back and check your answer. Okay, either of those equations would work, either point slope or slope intercept. But remember, you need to find that opposite reciprocal slope. The line was given to us in slope intercept form, so I can just pull that slope right out of 4 and then turn it into its opposite reciprocal of -1/4. And that is writing the equations of lines that are parallel and perpendicular.